All right, so let's start this off with you guys doing a quick warm-up here with these questions that are in your packet. So those first 5 questions there, what I'd like you to do, following the directions there, it says write 3 possible values for each statement. So you read the sentence, you give me 3 numbers that would work, that would make that a true statement. So just take about a minute here and fill those in. All right, so on number 1 here, I would like realistic values. So when it says there's a minimum of 15 people in the class, every one of these sentences is going to have some sort of phrase or word that's going to reference an inequality of some sort. So like in this first example here, I'm sure, I know you all picked up on it, this minimum word, minimum of 15. And that's going to indicate how many you wanted to go with. So can anybody want to give me your 3 numbers that you used for number 1 here? Sarah? 16, 17, and 18, you said? And would that continue on that way? So on and on and on. So if you had a number in that range. So the next question I have goes back to the original sentence, and it's this 15. Could 15 be a possible solution in there? Did anybody put 15 down on your paper as 1? Okay, some of you did. I agree. 15 could be a solution there. And I'm going to add that in there just to be thorough, because that's going to help us talk about what we're going to do a little bit later on. So yeah, these are all possible values. Anything that's 15 or more would work. Okay, how about number 2? This at most phrase. Give me your 3. Brendan? 46, 47, bless you, 48. Now, because these are all sequential, Brendan, could I keep going to the right, or would it be going back this way? Back this way. So we're looking at numbers that would be less than 46. So he included 48. Did anybody else put 48 in that mix? Good. 48 would be a possible solution there. All right, how about number 3? The temperature was less than freezing, which is 32 degrees. How did we write, or what did we write for our expression here, or numbers rather, Leah? What was the last one? On the record, I'm not ready for any of those temperatures, but certainly not negative 60. So I agree. All of those would work. But let's focus in here now on this 32. Did anyone include 32 in their description? Not many. Why did you not include 32, since most of us did not? Brady? So that would not include that number then, right? Exactly. So if it phrases it in such a way, we would not include 32. We would go anything that's below 32. How about number 4? No less than -1. Isaac? Okay. Could we have -1? A lot of you are saying it just says it's not less than -1. It could be -1, so I'm just going to add that in there. But -1 or anything bigger going up the number line would work in a case like that. Okay? Last one. Number of books needed is more than 12. What do we have here? Hayden? Would they keep going? What about 12? No, it's more than 12. So we're looking at 13 and beyond. Okay? So I was highlighting those phrases because we're going to come back to that here a little bit later as we work on identifying different phrases that mean inequality statements. You guys understood this part. I knew you would, but you've already learned how to associate phrases with solutions just like that. All right, so two quick definitions here. First is an inequality, which we defined this back in unit number 1 when we were doing a comparison. When we first got introduced to negative numbers, we were comparing. We've used these symbols before. And then a solution, we defined that when we were doing equations. Question. On the side counter here. So any values, I put plural because we just showed an example. With equations, remember, when you solve equations, you get one specific answer, unless it's one of those all real number solutions or no solution. But anytime we solve an equation, we're getting a single value, whereas in inequality, you could have an infinite number of values or solutions. All right, so let's talk about these phrases. And I got this table here. You have it on your notes. Where we're just going to list some popular phrases or descriptors for each. So what is this first symbol? You'd be surprised how many times we mix up our basic inequality symbols. What would we say there for the first one? Ellie? This one here is less than. That's why we go over this stuff, right? So we're going to put less than for that one. Which one makes the one below it a greater than? Leave some room because we're going to add to these. We're going to add some other phrases in here. So then what would this one below mean? Jack? Yeah, so we'd say less than or equal to. So then this must mean greater than or equal to. What about that last one? Finn? Yeah, we'd say not equal to. You don't see that one very often, but I wanted to at least acknowledge that it does exist. But let's start populating these with more phrases. Any other way to say less than you can think of? Hayden? You could, yeah, but if you're comparing them, you would write typically a less than symbol there, but 7 is not equal to. It's more, well, I'll show you later, actually. I'll show you an example specifically. Do you have another one, Ellie? Smaller than? Fewer than? Yeah, I'm going to write both of those. Smaller than, fewer than. You guys can write as many as you want of these. Like if you don't feel like you need to write them, it's up to you. Just be able to identify them, but I'm just putting them up here so you know. So greater than would be, some people say bigger than. Sarah? Larger than, bigger than, yeah. Sometimes you'll see the word exceeds. Okay. More than, right? Okay. So we go to less than or equal to. There was one from the previous 5 that you guys already did. So back here. One of these is a less than or equal to. Which one, Zoe? Yeah, when we say at most, anything else on this? Maybe, Isaac? What do you, all right, what do you have? At least, good. Well, while we're bouncing around here, where would you put this one? The minimum. Which category? Quinn? Say that again. Greater than or equal to. Yeah, down here. So then what else could we put up there for less than or equal to? Leah? A maximum. Yeah, here's what happens, though. Sometimes we mix these up because we think, when we hear the word maximum, we think max, like greater, bigger, right? So it's like, oh, I associate maximum with greater than or equal to. No, we're saying the solution can be a maximum of something, meaning like that's the ceiling. It can't get any more than that, but it has to be less than. Okay? Ellie? No less than. Which one would I put that on? The greater than or equal to, right? So that means we could come up here and put a no more than or no greater than. Leah, you got to know? Doesn't exceed. Yeah, I'm running out of room here, but you could write that. Sure. Those are the key ones, the most popular ones that you'll see. There are other ways to say them, but Isaac? Inequivalent, you said? Yeah. Yeah. So an example of like a not equal to is if I was saying, okay, x is not equal to 1, then that means x could be what? Did I hear anything but 1? Yeah, exactly. 1 is the only time when that thing would not work. It's rare that you'll see that, but just that's an example. Okay? So let's start writing some of these here. All right, there are less than 4 people studying at the library right now. So the first example, when we were back here, I had you just come up with numbers. But back these ones here, I'm actually going to have you write the inequality. But I don't know how many people there are. The number of people could vary, could differ. So I need a variable. So maybe I say P equals people, and I write an inequality statement using the variable P. So the number of people, how would I write it? Very literal, right? Finn? Yeah, just don't mix up your symbols, and there's your inequality right there. Number of people is less than 4. Here's what I always get. I say, okay, well, what values of P could there be? And you're like, well, 3, 2, 1, 0, -1, -2, -3, -4, right? All the way down. What's the problem with that? Any issues there? Isaac? Exactly. You can have negative people, you just can't have a negative amount of people. Negative people, the pessimists of the world, yes, right? You can have those people. You just can't have a negative amount of them. Now I'm confusing myself. Yeah, negative people. Bring you down, right? But Isaac said it, you can't have, I can't say, well, there are -4 people currently in the library right now or wherever. Okay, you can't have that, of course. But I do not need, because people always say, well, don't you then have to say P has to be, greater than or equal to 0, but also less than, I don't need that right now. Okay, I understand. You guys, I trust that you have the ability to understand that we cannot have a negative number of people. All right, so that's fine for me. If you wanted to get super specific and put or P is greater than or equal to 0, but less than or equal or less than 4, that's fine too. Okay. All right, you must be. Oh, here's a one like I referenced earlier. This is a dated one though. This is a Kennywood reference, but do you guys even remember when it used to be called the Steel Phantom? Yeah, it's yeah. Well, it might have been close. You guys are what, born in like 6, 5, 6, maybe. All right. So, history lesson. Yes, the Phantom's Revenge did used to be called the Steel Phantom. I don't remember when the name switched over. Um, how would you write? And that's actually inaccurate too. Now it's 52 inches. But let's go with the 48 for writing this. What would you write for your inequality here? Mikey. Height has to be greater than or equal to 48. Remember, I used the example before about my son on the jackrabbit. The jackrabbit might be 38 inches or 40 inches, something like that. So the height had to be, his height had to be that or more. That's why we're going greater than or equal to. Yeah. Yeah, these are examples. Oh, it's been adapted over the years. This is just an old example. Yeah. All right. How would I write an inequality here? Go ahead, Sarah. Less or equal to, you mean? Yeah. And P would be like the number of bonus points here. And that's that one. Remember I said, when you see the word maximum, a lot of times we get, I shouldn't say a lot of times, sometimes kids mix those up and put greater than in that case. But no, the points cannot be greater than or equal to 18. Or it can't be more than 18, but it could be 18 or less. Okay? Yes, Sarah. No, that's a great question. She said, would the variable always be before? And the answer is no, but here's the deal. If I write it this way, would I do this? You gotta flip it. Yeah. Unlike the equal sign. Remember the equal sign, it didn't matter. It's just an equal sign. You reverse an equal sign, what's it look like? An equal sign, right? So it doesn't make a difference. But here, when you reverse your numbers and your variable, you have to also reverse the inequality. So in this case, the inequality is facing away from the variable. It must do the same on this one. Just be aware of that, because sometimes that's what happens. Kids will mix it up. Like they'll write this and be like, wow, oh, I'm sorry. They'll put the 48 first, And then they'll just forget to acknowledge that the inequality needs to reverse too. So just watch out for that. Okay? Yes, Abe? Yes, that would work. Yeah, because if you reverse this inequality, 48 less than or equal to x. Yep. All right. Just to give you a variety of types of questions you might see here. Here's one where you have an inequality statement. S minus 9 is less than 4. I don't know what S is, but if they told you what S is, which now they do, you could test to see if it's true. So the question is, if S is 6, is that a true statement? How? Prove it to me. Those of you that are saying yes, it is. Brendan? We're making a comparison statement. And this is a true statement right here. Negative 3 is less than 4. Okay, the other one, which was not, I don't have it up here, but it's, what is it, 14? And A is 36? Okay, so let's see. Is that true? How many are going, I heard no first. How many are going false on this? Oh, a lot of you are? Okay. Well, prove it. Why is it false? How is it false? Maybe it isn't. We'll know. Mikey, I heard you say false. Why? So the inequality becomes 14 is less than or equal to 12 plus 1, which we all know is 13. So 14 is less than or equal to 13. He's right. That's not true. So that would be a false. All right. So here's something that I discovered. It was kind of brand new to my last group. How do we graph these inequalities? Let me lead you into this here first. So I gave you the inequality. Y is less than 3. Nothing tricky about that. Whatever the value of y is, it just must be less than 3. So if I went through and started highlighting or graphing possible solutions to this inequality, you guys remember how do you plot like a single point on a graph? Like if I said plot x equals 2, what would you do on a number line? Do you guys know that? Ellie? Yeah, you put a dot or a point on at that location. Okay, that's how you plot points. All right. So if I'm saying y is less than 3, and we start to accumulate values, we could say, well, you know, negative 10 is a solution, negative 9. All of these are solutions to this. Yes? Well, what don't you like about that? What's wrong with that? Leah? You don't like the dot on the 3. So we wouldn't include that, right, as a solution. So I'm going to get rid of the 3. Okay. So then is this how I would graph the solutions? Does that represent every possible solution? No, it doesn't. Because could y be like, I don't know, 1.5? What about 1.8? Yeah. It could be anything in between these. And how many numbers are there between, let's say, 0 and 1? An infinite number, right? So you're going to be busy. So what do you think we do? Sarah? So you're saying draw an arrow? Some people like to draw the arrow. Some people like to shade. Like I know people like this. Typically when I do it, I'll just like kind of highlight or shade. But she said go all the way down to the arrow And by hitting the arrow, that means that it's going to go with the arrow. So if it continues on, so would my shaded line or solutions. However, that's still not right yet. Because the way I have it graphed, I'm looking at this thinking, well, what about 2.5? Isn't that a solution? But I don't have it graphed here. So, Mikey? I like the circle on the 3, like you said first. So that's what I'm going to do. I'm going to put the mark at 3, but I'm going to shade everything to the left of that. Okay, so now when you look at that and you think, okay, well, I get that part. Now I've got everything between like 2 and 3. But isn't that saying 3 is a solution? What is designating 3 is I guess, what is disqualifying 3 from being a solution, I should say? Quinn? Yeah, it's an open circle. A hollow circle means it's not being included in that particular solution set. All right, so let's go down here and try this next one. Tell me what type of circle, where, and which way we shade. Give me the circle first. Type, where, shade. Sarah. Not 9. I don't want to do any number but what I see. I'm going to put a circle at the 8. Tell me about that circle. So I got my bullseye there. Leah? Why? It's including the 8. It is. So I would circle it and fill it in. And then which way did you say to shade, Leah? To the left. Anything for T must be less than, but it could be equal. Shading or controlled scribbling, however you want to call it. Okay, that's good enough for me. All right, so there's your difference between open and closed. All right, give me this next one now that we've seen each. What do we think? Brendan? Filled in -7, okay. Going to the right. M is greater than or equal, so I agree. Bring it all the way. And again, make sure you go to the arrow here so it stays with it. All right, the next one, I don't think I have the description, but doesn't it say, what is it? V is greater than 2. Thank you. Okay? So how do I do it? Amelia? Open it 2, okay. Go to the right. I agree. Okay. Okay, and then the last one, I think it says it's not negative. Is that correct? Does it say like n is not negative? All right. So what would that look like? Go ahead, Brady. Mm-hmm. What do you guys think? So n is not negative, so we're saying n can be anything that's above 0, right? But some of you don't like that. Ellie, you don't like it? Yeah, and going back to Brady, what you said 0 is not, it's neither negative nor positive, right? So we're going to include it here because it says it's not negative, and so 0 doesn't fit into that. It fits into that not negative category. You say it enough times, you start to confuse yourself, I know, with all these nots, but that would be how it would look right there. Okay, so 0 could fit into that category. So what if I changed it and said n is not positive? Would I then go like that? Why not, Finn? Same logic, yep. You would have to go that way with it. Tonight, when it asks you to graph, I'm not going to give you lined graph paper or anything like that. You guys do not have to get super detailed. So like what you can do tonight, let's say it's saying to graph x is greater than 2. All you really need, or all I need from you, give me a basic number line, give me a couple points nearby. It's greater than 2. Show me open circle. Show me that right there. That's all I really need. Just prove to me you know how to identify solutions to that. Okay?